Salutations, Internet. Good time zone. As you may have noticed from the previous episode, it was a little bit shorter than it really needed to be. As can be seen if I zoom out too far, as can be demonstrated by just how little was actually written. But that, I argue, is because what I am going to do today is going to be a little writing intensive. So let's not spend too much time. Let's get into it. And I think I'm going to start by doing a really quick review. For the first part of this mini-series, we took a look at the perifocal reference frame. We discussed what that meant and what equations for position and velocity would look like in this reference frame, as can be seen by these underlined equations here. And with this expertly drawn diagram, if I may say so myself, we then took our position and velocity equations, which are good for any time, or for any position, I suppose, in the perifocal reference frame. And we brought them over to here. We set them to an initial value. This would be values that we would perhaps see when we first looked at this, at an incoming body. Excuse me. For example, these would be references that we would find, that we would discover, I suppose, on an incoming body that we just noticed. We then reversed the equation so that we could find what P and Q are. So there. So we have definitions for R and V, and we have definitions for P and Q. And I think that's enough of the alphabets for us to get started with today's video. So if we start with our position and velocity equations, which are good for any combination of distance and angle, and then we substitute P and Q here for P and Q here, well, we get a very complicated equation that will eventually simplify up into something quite nice. So let's go ahead and get started on that. I'm going to get started with radius, so r at any time t will be equal to the first part. I'm going to use curly braces for the whole thing if I can. R times the cosine of theta, any theta, times p. One more bracket. And that's going to be mu divided by h squared minus e plus the cosine of theta naught, because p is defined at the initial point. That is r naught's direction, plus minus r naught over h times the sine of theta naught. In the v naught direction, perhaps it is best to say that it is scaled by v naught. Okay, well, we have now this. Oh no, we do not. We do not have the whole equation. This is only the first half of it. And I have run out of space there, so let me scroll down a little bit. Plus quantity of r times the sine of theta times q which is mu by h squared times sine of theta naught r naught plus the second term is r naught by h cosine of theta naught scaled by v naught. Before I write v, I am going to sort of simplify. I'm using big air quotes around that. I'll simplify this equation so that we don't have a huge number of terms floating around here. So we don't have 6 terms, but instead we'll have 4 terms. So I'm gonna do this so that my handwriting can hopefully be all right. And we will combine. So to start, we have r mu over h squared and r mu over h squared. That is good. If they were different between the two terms, then we would have done something wrong. So let's go ahead and write down r mu over h squared. This will be times, I have cosine times e plus cosine. Cosine of theta e plus the cosine theta. All right, this now gets added by the second term, which is sine times sine. So that is sine of theta times the sine of theta naught. That is all in the r naught direction. That makes that nice and easy on us. And we will add the v term, which is going to be r times r naught by h and r times r naught by h. Okay, good. Again, they match up. That is definitely a good sign. It puts r times r naught divided by h. And we need to remember the minus sign for the first term. I cannot tell you how many times I had to throw out a take because I was not carrying over the minus sign. Not. There we go. That's the first one. And then the second is a plus, and it's sine cosine. Sine of theta is the cosine of theta naught. And that is in the v naught direction. Okay. So this isn't, strictly speaking, the final equation that we were looking for, but what I can tell you is that we will be coming back to it later, so I will mark it with a green star. Now, we're going to do the same thing with v here, and I have notes written off to the side so I don't have to keep scrolling up and down. So copy it over now if you wish, or you can follow along with me. Give me a blank canvas. Okay, so we have v at any time t is equal to, our first term is minus mu by h. I can make that look more like an h than an n. There we go. Times the sine of theta. This will then be scaled by p, which we just covered is mu by h times e plus cosine of theta naught. That is in on-off direction. We'll then add minus R naught by H times the sine of theta naught scaled by V naught. We will then add the V component, which is, well, we will add the next component, which is mu by H E plus cosine of theta times Q, which is mu by H times sine theta naught, R naught direction, plus not by H. Use the cosine of theta naught. So as you can tell, there's a lot going on within each of these equations, R and V. It is very easy to get things mixed up when you're looking at your notes. Ask me how I know. All right, same as before, we are going to combine like terms so that we have a term for R and a term for V. Mu by H and mu by H, mu by H, mu by H. Oh, look, something didn't get copied down right. Looking at my notes, that should be an H squared for both of them, which means that we should really have a mu, we should really have a mu squared by H cubed for each of our R naught terms. Strange that I didn't copy that down for both of them. Anyway, now we can combine the R naught terms. So we have sine of theta times E plus the cosine of theta naught. That, however, is negated, so I will put the minus sign there. I will then add E plus cosine of theta times the sine of theta naught, that is all scaled by R naught. And then similarly with V naught. So we have mu by H and R naught by H. We should have mu R naught by H squared. Mu by H, R naught by H. Sure enough, mu R naught by H squared. We will then scale this quantity by, so we have a minus sign and a minus sign, then minuses will cancel out. So we will have sine of theta, sine of theta naught, plus E plus cosine of theta times the cosine of theta naught. Always match up your brackets. And there we go. Similarly, I will go ahead and select it, thank you. I will go ahead and mark this one with a star. And the reason why I marked both of these equations with a star, I will will not be able to fit both of them properly on here. But that is because if we go back over to the first episode in the miniseries and scroll up, here we go. We have F times R naught plus G times V naught for our R component. And for our V component, we have F dot R naught plus G dot V naught, which we have for our R component, a term times R naught and a term times V naught. Similarly, for our V, we have these. So give me one moment while I copy these down. I'm gonna scroll down here to copy them down. One moment. All right, welcome back. So I have taken the liberty, as I said, of recording each one of our components, of our Lagrange components. So we have our F up here, our G, our F dot, and our G dot. There we go. And that should leave us with these equations. And these are perfectly fine equations. These are perfectly valid. There's nothing wrong with them. Except that I do not necessarily want to... there's just a lot going on here in each one of these. It is possible to simplify it up. So if we go up to here, let's go back up to the top and slide over. Oh, look. Can I fit all of them? My handwriting was just slightly too big. And I realized I missed one second. All right. So let me... No, I don't want to slide. I want to zoom. There we go. All right. So we have a list of helpful equations. Yeah. We have a list of trig identities. Yeah. The main takeaway from this is that we want delta theta. We want the difference between the angle that we are currently at and the angle that we started with, which is especially helpful if you don't know what the periapse is. So all you need to do is just measure the angular distance between your initial point and your secondary point. So with this in mind, I'm going to go ahead and do one of these, and I'm going to zoom back in for it. I'm going to go ahead and simplify F. So let me copy it back down. All right. So that is the copy over of F. And like I said, we want to simplify it. So every one of these equations that I have written up here, between all 5 of the trig identities, that's close enough, between all 5 of the trig identities and these extra helpful equations up here, if we were to begin applying them, so we have R, we have mu, then H comes from the parameter equation. So if we reset that so that it is the square root of P mu squared, well, the squares, sorry, 1 second, the square is going to cancel out with the square roots, the mu is going to cancel out with the other mu, and so that's going to leave us with R over P, which I will rewrite on the next line. We can then distribute this, so I will go ahead and do that. which, yes, I will take care of that on the next one. E times the cosine of theta plus cosine of theta not plus sine of theta sine of theta not. Okay. As promised, we have R over P. It is then times the quantity of, and I have an E here, which I do have a note for up here. E can become P over R or P over R naught with all of the rest of it. So do we want it in terms of the initial values or the non-initial values? Since I have a cosine of non-initial values here in that cosine, I am going to go ahead, select there, I'm going to put the non-initial variance. So P by R minus 1 times the cosine of theta over the cosine of theta. Cosines will cancel. Plus, now I have cosine times cosine naught. It's going to be this equation here we're going to refer to. So 1/2 cosine A minus B. 1/2 cosine theta minus theta naught. Right, I said A minus B. It is A minus B plus cosine of A plus B plus the cosine of theta plus theta naught. And we can do the same thing with sine plus 1/2 sine A sine B. That is the exact same equation as before, except we are subtracting the two cosine values. Cosine of theta naught minus cosine of theta plus theta naught. Okay. As you can guess, something in all of this mess is going to cancel out. And that looks as though it's going to be the theta plus theta naught terms. So cosine theta plus theta naught cancels with minus cosine theta theta naught. Theta plus theta naught, you know what I mean. We will then add these two together. Be 2 times cosine theta minus theta naught divided by 2, which will give us R over P. Realize that with the bracket off over here, not that it matters. That is going to become R over P times the quantity of P over R minus 1 plus cosine of, and I have already written theta minus theta naught as delta theta, so let's go ahead and put in delta theta here. And then we can distribute our R over P. We will have then, that's going to become 1 minus R over P plus R cosine, do R times cosine theta. Sorry, R cosine delta theta over P. And I can take the R over P to the outside of this little bit, which leaves us with 1 minus R over P times 1 minus cosine of delta theta. And that is indeed F. really, both of these, oops, went too far. Both of these are correct and valid to use. And same thing with all of these other letters. All these other letters, all these other variables, these other Lagrange coefficients. Will appear on the equation sheets in future videos. Let's go back up to here. Now, I think it would be a fun exercise to take all of these other variables, g, f dot, and g dot, and run them through the same process that we just went through up here. I think it would be fun for you, dear viewer, to go through this as an exercise. However, to make sure that you all reach the correct answer, I'll go ahead and write down all of them here. R times R naught times the sine of delta theta over the square root of P times mu. We have F dot is equal to the square root of mu by P times the quantity of 1 minus cosine of delta theta over P minus 1 over R minus 1 over R naught times the tangent of delta theta 2. And then G dot is 1 minus R naught over P times 1 minus cosine of delta theta. And all of these are equations that will also appear on the equation sheet. Now, if you do decide to go through and solve for all of these on your own, I will tell you that at some point, you may find it useful to use this identity. 1 equals fg dot minus f dot g. That may come in handy. Otherwise, every other equation that you could use, I zoom in the right direction, not too far, there you go. Every other equation that you could use is going to be located within this box. And I think that's a good place to end this video. That's going to be the last video for the year, and I am quite happy that it ended on a note of finishing this micro-series. We've gotten to a good stopping point, and I don't think I can wrap it up any better than that. So, thank you all so much for stopping by.